All right, let's jump right into this explainer. We're unpacking a massive paradigm shift happening in science and health right now in 2026. For decades, human healthcare was kind of stuck relying on blunt, symptom masking treatments. You get a headache, take a pill. You have a disorder, we just treat the surface level stuff. But looking at the frontiers of medicine and neuroscience today, we are officially past that. We're stepping into an era of proactive, hyper personalized root cause solutions. We're not just putting band-aids on symptoms anymore, we're literally reprogramming the human body at its most fundamental levels.
So, to really grasp this era of biological precision, we're going to journey through four key frontiers. First up, the precision medicine era. Then, we'll look at hijacking the body's systems. After that, decoding perception and sleep. And finally, rewiring the nervous system.
Okay, Section 1, the precision medicine era. Let's take a look at our new medical arsenal. The days of one-size-fits-all mass-produced medicine, yeah, they're fading fast. We've officially entered the era of truly individualized medicine, which is just mind-blowing when you really think about it. We're now seeing the rollout of fully personalized CRISPR therapies. Instead of giving you a drug meant for millions of other people, scientists are tailoring gene therapies entirely to your specific, unique genetic makeup. This rapid acceleration means we can actually go in and correct inherited anomalies based exactly on the blueprint of your own DNA. It's literally healthcare designed for a population of one. And this crazy precision goes way beyond just genetics. Take cancer, for example. We're now targeting tumors with unbelievable accuracy using next-generation radiopharmaceuticals. What scientists are doing is pairing molecules that specifically hunt down cancer cells with highly potent radioactive agents like actinium-225. Now, actinium-225 is a powerful alpha-emitting agent, which basically means it packs an incredibly destructive punch. The truly astonishing part? It takes just a microscopic fraction of this stuff to completely obliterate a target cell. To put that into perspective, traditional radiation acts a bit like a floodlight. Sure, it's effective, but unfortunately, it can damage surrounding healthy tissue while trying to hit the tumor. These next-gen radiopharmaceuticals, though, they act like a laser. Doctors can now deliver lethal energy precisely to the tumor, completely minimizing the collateral damage to the healthy cells around it. You get maximum impact with virtually zero friendly fire.
Moving right along to Section 2, hijacking the body's systems. This is all about using our natural defenses.
So medicine is now literally hijacking the body's own natural systems to fight off rogue proteins and chronic inflammation. We aren't just pumping in outside chemicals anymore, we're putting the body's own internal machinery to work. A perfect example of this is targeted protein degradation, or TPD for short. TPD represents a massive new frontier in smarter, significantly less toxic cancer therapies. Instead of flooding the system with harsh chemicals, TPD harnesses the cell's natural waste disposal system. It essentially tricks your body into taking out its own cellular trash. And this isn't just theory. This innovative approach is already happening in the real world right now, with drugs like vepdegestrant for advanced breast cancer. Here's how it works. TPD operates in this beautifully simple three-step process. First, a targeted molecule goes in and acts like a molecular sticky note, flagging the exact disease-causing protein. Second, that little tag triggers the cell's natural waste disposal system. Think of it as the cell's own internal garbage truck. And finally, step 3, the toxic protein is completely dismantled and destroyed. It flags and eliminates the exact problem proteins, leaving the rest of the healthy cell perfectly intact.
And it's not just cancer where this system hijacking approach is an absolute game changer. Take autoimmune diseases. Bruton's tyrosine kinase, or BTK inhibitors, like the drug fenebrutinib, are showing absolutely unprecedented success in treating multiple sclerosis. Now, MS has notoriously been incredibly tough to treat, but these inhibitors target the chronic inflammation in the central nervous system head-on. This is a huge leap forward, not just for relapsing MS, but also for primary progressive MS. It's offering real hope where, honestly, there used to be very few options.
All right, Section 3, decoding perception and sleep. It's time to understand the brain. Transitioning from the immune system up to the brain, our third frontier explores how we're finally opening up the black box of the nervous system. Recently, the 2026 Brain Prize Selection Committee recognized pioneers David Ginty and Patrick Ernforce. Why? Because they mapped exactly how the nervous system detects and processes somatosensory stimuli. We're talking about the literal cellular architecture of touch and pain. By finally understanding this wiring, they've opened major new doors for chronic pain treatments. Think about it. If you know exactly how the pain signal is built and transmitted, you finally know exactly how to turn it off.
We're seeing a similar targeted leap with narcolepsy type 1. For the longest time, the standard of care involved traditional stimulants. But as you probably know, stimulants only mask the symptoms, right? They just force a tired brain to stay awake. Well, now, a totally new class of oral drugs, specifically orexin A receptor agonists, are fundamentally shifting how we treat this disease. Instead of just using a blanket stimulant, these agonists target the brain's underlying loss of orexin signaling. They get right to the actual root of the problem.
And why this matters for the patient is literally night and day. Instead of that jittery, forced wakefulness you get from a traditional stimulant, targeting the orexin signaling corrects the underlying biology. This leads to substantial, real improvements in wakefulness. It's basically the difference between patching a leaky pipe with duct tape versus, actually fixing the pipe itself.
Finally, Section 4, rewiring the nervous system. Let's look at macro-level recovery. So, zooming out to look at the macro level of the brain and spine, proactive, non-invasive brain imaging has crossed a truly critical threshold. Years prior to a patient ever even feeling sick, researchers can now detect subtle, circuit-level changes in the brain. Then, months prior, doctors can deploy proactive, precision-tailored interventions. What this means is that by the time we hit time zero, the point where a disease would traditionally become obvious, we can actually prevent the outward symptoms of neurological disorders from ever appearing. We're literally stopping the clock before it even chimes.
But you might be wondering, what about when the damage has already been done? Well, this is where science fiction truly becomes clinical reality. We're seeing unprecedented neurorecovery for spinal cord injuries right now. By combining targeted physical rehabilitation with adaptive electrical stimulation, researchers are effectively creating what they call digital neural bridges alongside brain-computer interfaces. They're using tech to literally bridge the gap over damaged nerves, allowing signals from the brain to actually reach the limbs once again. It's just wild.
This is an astonishing breakthrough because it means we are fundamentally rewriting the medical textbooks. We're no longer viewing paralysis as a permanent, untreatable barrier. Instead, thanks to adaptive neuromodulation, researchers are reframing paralysis as a modifiable network disorder. It's a network issue. And like any network, if you have the right bridges and the right signals, it can be modified and repaired. As we wrap up this explainer on the incredible precision of 2026, I want to leave you with this final thought. We've seen how personalized CRISPR corrects our genetic blueprints, how targeted protein degradation hijacks our cellular waste, and how digital bridgers are reconnecting paralyzed nerves. So with a medical arsenal this smart, this precise, and this powerful, what previously incurable condition will humanity conquer next? The frontiers of medicine are expanding faster than ever, and I, for one, absolutely cannot wait to see what's over the next horizon.